Hi everyone, and welcome to the next exercise on maximum coverage location problems. You have to determine a new location for an ambulance station in your region, and you have to consider and to cover 3 villages which are denoted 1, 2 and 3. And we know that we have 1,000 citizens in all of these 3 locations, so there's no difference in the population size. And we have 2 potential locations for ambulance station A or B. Okay, and both bases can cover a particular radius within the response time. So let's assume 8 minutes, and we can see that A. So if we would choose location A for our ambulance, then it could cover village 1 and 2 within the target response time, which maybe be 8 minutes, but it takes 1.5 times more if we would like to reach village 3. So it's really far away. Okay, if we choose B, okay, and the radius of B, you can see here that you can only reach village 2 within 8 minutes because the radius is here, only the second demand node is covered. However, you need 1 and 2 times the target response time to reach village. So village 1, 2 times the target response time, and village 3 within 1.3 times. Okay, so the question is now, if you know these numbers, then the question is, where would you locate the new ambulance station if you wouldn't use any kind of optimization model or some kind of quantitative analysis, just intuitively? So if we assume, or we'd like to go for fairness and to have some kind of equal access to ambulance services, then you might choose, at least intuitively, the location B. Okay, because we think that it's at least is better to reach village 1, to go to this one or to this demand node. Roughly this needs the same time, instead of choosing A but reaching people in village 3 too lately. Okay, so if we want to be fair, we would rather go for B, to be nearer in the center, where we can reach 1 and 3 within a similar time frame. Okay, so that would be our intuitive approach. And now the question is, if you would use the maximum coverage location model, then where will you locate the new station? And you remember the notation and the model for this particular problem. You have the demand of vertex I, so this is 1,000 in our case. The number of available ambulances, you can only assign 1 ambulance. This is given, you cannot change that anymore. And the decisions variables are why I is 1 if demand node village 1, 2 or 3 is covered by at least this 1 ambulance, and xj is the number of vehicles in J, so in our case it's only 1. So that means the question is now, if you would choose this model and if you would use it, would you come to another conclusion? So as I said, we have P is 1, we have D for every location 1, 2 and 3. We have 1,000 people in each village. Okay, so the question is, if we would choosing B, okay, what can be then covered? Okay, so then if we choose B, then we can only cover demand node 2. Okay, so that means B is only part of W2. Okay, because this is the only location that can be reached within 8 minutes, for instance. And that means that our objective function would be 1000 in village B, in village 2, sorry, multiplied by y2. Okay, because this is the only one that we can have, otherwise it's for one. So y1 is 0 and y3 is also 0, because we cannot reach that in within 8 minutes. So that means our objective value function will be 1000. Okay, so this is the first option. And what if we choose EA? Okay, if we would choose location A, okay, then we know that at least 1 and node 2 would be covered. Okay, so that means we have an objective value function of 1000 for village 1, because that can be covered, plus 1000 for village 2. Okay, and in this case we cannot reach the village 3. So overall we have an objective value function of 2000, and therefore of course we would choose A. Okay, because with the number of ambulances we have available, we can maximize our covered demand by choosing A. But then of course we are not reaching the third village on time, not even near in time. Okay, so this is the disadvantage. Okay, therefore the question is now, how could you change the model so that you can also reach location 3? Okay, so let's assume you have chosen B intuitively, because you would like to reach everyone at least within a similar time frame, instead of covering 1 and 2 and not reaching 3 at all. So the question is, how would you choose that one then? So the model one. And one very intuitive also idea is simply to propose a model that could maximize the average response time. Okay, or let's say minimize the response time, right? So for instance, we can modify our objective function by now minimizing, okay, some kind of distance between demand node I and the ambulance location. So sum over I and sum over j, and then having this demand weighted objective function, so demand of each node and y if it's covered or not. Okay, so we could choose that one, and t of course is some kind of response time between the demand node and ambulance location J. Okay, so this is pretty easy to do that, okay, without that we have to change anything within the constraints. And with this, the model would rather go for choosing than B. Okay, and the last task is if you would be the ambulance planner and you would have to locate P ambulance stations in Stuttgart, Freiburg, Karlsruhe, and so on, and which are very densely populated cities, and then we have some kind of rural regions where the population is not that high, okay, such as in the Black Forest. So the question is, what effect will it have when you use the objective function just proposed in C? Okay, so how will the solution differ to the one you obtained with a classical maximum coverage location problem? Okay, so in the first version, you have chosen, if you choose the standard maximum covering location problem, then this would give you as an optimal location A. But intuitively, or for fairness reasons, you would rather go for B. And the question is, so what kind of effects does this change have? And here I would like to let you think about that, okay, and we can have a discussion on site. Okay, and with this I would like to thank you for your attention.